Kalispera σας. Good evening. Welcome. I'm Michael Cosmopoulos. I'm the chair of Greek Studies here at the University of Missouri St. Louis. And on behalf of our university, on behalf of AMSL Global, which is the unit that houses the professorship, and our colleagues and students, I would like to welcome you to this 11th annual Dr. Nicholas Matsakis Memorial Lecture. I think I don't need to say much about Dr. Nicholas Matsakis. We all know who he was, a tremendous figure in Hellenism, one of the major supporters of the Greek community, and a driving force behind the creation of this professorship almost 30 years ago. This lecture has been endowed by his children in his memory, and they also endowed the Matsakis Greek Culture Center, as you know, which is over in Lucas Hall. And this is, that is a multifunctional space with a library. It houses the archives of the St. Louis Greek community, and we use it for classes, seminars. It has a small museum of Greek art, and it's open to the public and to our students pretty much every day. So the details are on the website. Before I start, I'd like to recognize a few people who are with us today. Mrs. Liana Constantine is the director of AMSL Global. Liana, would you stand up? And she's been extremely supportive of everything we do in Greek studies. And Liana, thank you very much for all your help and support. Also, from Greece, our new father, our new spiritual father at the Assumption Church, Father Panagiotis Kostoulas. Father, welcome to St. Louis. We are honored and very happy to have you here. Kalos ήρθατε. Also from Greece visiting is a former colleague of ours, Professor Nikos Poulopoulos. Niko, πού είσαι? He taught here for many years. Nikos is writing 2 books on the history of the Greek community, and he's here for just a week doing archival research on the history of the Greek community. Niko, kalos ήρθες. It's a pleasure to have you here again, even for a few days. Last but not least, I'd like to recognize the 2 Matsakis brothers, Ilya and Dimitri. We are always a joy to see you both. Stand up, please. People want to see you. So we're laughing, but I have some sad news, unfortunately, because in the past few months, the Matsakis family lost 2 beloved members. Mrs. Theodora Matsakis died last November at the age of 99. And she was an amazing lady, an amazing woman, an amazing supporter of anything Greek, an amazing musician, and an amazing wife and mother. A few months later, Aphrodite died, the beloved sister of Elias and Demetrios, and we're all devastated by the loss of both these wonderful, amazing individuals. So please accept our condolences and our sympathies and our love. We will have events to honor both. In November 18, we will have an event to honor Mrs. Theodora Matsakis, and we'll have because the next year's schedule is already done. At some point in the next couple of years, we will have an event to honor also Aphrodite's memory. But if you don't mind, I would like to ask you to please stand up and keep a moment's silence for these 2 amazing human beings and Greeks. Thank you. Thank you. Ζωή σε λόγους σας, Δημήτρη και Ηλία. One more thing before we begin. Could you kindly ask you to turn off your phones? Thank you. Mute them or power them off. Today's speaker is Dr. Demetrios Matsakis, and he needs no introduction. He's one of ours. Demetrios was born, of course, here in St. Louis to Dr. Nicholas and Mrs. Theodora Matsakis. And since he left St. Louis, he followed a very distinguished career as a scientist. He received his bachelor degree from MIT and his PhD from University of California at Berkeley. He started as a physicist working with space stuff, right? And then he was recruited at the US Naval Observatory to help them keep time. And it's not as simple as it sounds. It's quite the opposite. It's a very complex operation, especially because this involves the military and the Navy. And for the past many years, Dr. Matsakis has been Mr. Time, basically, for the United States. He retired 4 years ago. He still consults with companies. He still has his connections with St. Louis. And because he's a scientist and because Greek scientists have contributed so much to civilization, I thought it would be a wonderful opportunity if he could talk to us about both his own experiences and also about Greek science in general. So, Dr. Matsakis, we are honored to have you here. We're all yours. Thank you.
Get started. I'm all right. So, starting with a confession, I didn't want to give this talk, and when my brother and Mike called me up and said to do it, I said, I'm not qualified for that. And Elias said, I've known you all my life. You're a scientist, aren't you? And I said, yeah. And then he said, and you're a Greek? And I said, well, maybe. And then Mike hit me with, and you have a whole year to do it. When do you want it to be? So any day you want. So I chose a day halfway between American Easter and Greek Easter because I thought most of the audience only has a hazy idea of why they're different, and that's what they'd like to know. Maybe other things too, but that's the main thing. So let me continue and have to deal with this issue and my prejudice. I have full confession. My father raised me to say the reason America is the best country in the world is because it's an embodiment of Greek ideas, from democracy all the way through everything else. But I have to examine that, right? So I spent a lot of my year studying the issue so I'd know it better. I looked in the media. I looked at movies. For example, this one. And, all right, you might say one movie. Well, I looked at a few more, and they gave a consistent story. And then, I don't know how, but you know, the internet knows everything. So it wasn't long after I agreed to do it that I got an email that said some consider the first known scientist to be this guy, Thales. I didn't know who he was. I admit it. So I looked him up. That's what he looked like. And the first thing I saw, I had a laugh. Why did I laugh? Because that told me that just like scientists today complain about how our governments and our leaders don't pay attention to it, then we have the same problem. Because I knew that a little later, when King Xerxes of Persia invaded Greece, he conquered Athens, he burned down the Acropolis, and he lost the Battle of Salamis. He didn't give up. He decided to break Greek morale and conquer Delphi, the temple of Apollo, and teach the Greeks a lesson that their gods were no good. So,
because we are broadcasting this, speak closer to the microphone, because otherwise your voice doesn't.
Okay. All right. So he sent an army up there, and there was an earthquake. They got panicked. They ran away. And a little later, as you know, the Persians got driven out of Greece. So that's the start. But what else did he do? He predicted an eclipse. He did geometry. He measured all of these other things. And I have to stop myself from saying he's a Renaissance man, because this was before the Renaissance. But you know what Renaissance means, right? Latin for rebirth. It was a rebirth of classical Greek ideas in Italy. That was the Renaissance. And that happened as the Ottoman Empire was taking over Greek lands and eventually conquered Constantinople. And the Greek scholars went to Italy with their books and started things up again. But there was more to this guy than that even. He sort of got a cosmology going. He thought the Earth, by which he meant the land, was floating on an ocean. And that actually isn't far wrong, because what's the modern theory? The modern theory is that the crust of the Earth, which is what our land is only about 20 miles thick, varies a little bit, and below it, it gets hot and gooey and then liquid. And the crust itself has all these plates that get jostled around by the currents of the liquid. And when they rub against each other, that's what makes earthquakes. They get stuck and they get loose. So that's the current theory. So let's get to a student, Anaximander, of the same island. He took it further. He thought the Earth was floating in infinite space, and he too argued that the universe followed laws. For example, thunder and lightning were not due to Zeus's anger throwing thunderbolts around. It was from clouds hitting each other. And he's absolutely right about the earthquakes we're doing to this. The Atlantic, down the middle of the Atlantic, as you probably know, the two plates are going apart. There's a subduction zone, there's a ridge. And Iceland, which sits on top of that zone, gets a lot of earthquakes. He believed that humans came from oceans. And one of his students introduced the idea that we came from outer space. You might think it's a lot of fiction to this. Well, in fact, Lucian wrote the first science fiction. And it's kind of interesting stuff about people living on the sun and Jupiter and having wars with each other. He didn't know the sun was hot, I guess. But this is the most interesting about him. He invented the gnomon. Before him, sundials were just a stick coming up, which was fine to tell the time, but that meant in the winter and the summer, the rate of the shadow would be different. So if you wanted to know the time, you'd have to calibrate it for the time of year. He realized if you pointed at the North Star, then you didn't have to calibrate it. It would be the same winter and summer. And we're going to hear about this further on, about the value of the gnomon. We come to Pythagoras. I think we all know the Pythagorean theorem and all that stuff. But less well known is that he discovered the concept of the octave, and he designed musical instruments to take advantage of that so they would sound more pleasant to the ear. Okay, he was a vegetarian, but he had some funny ideas. He would not eat beans because he thought they were the souls of his ancestors. And in fact, it is said that he died when a mob was chasing him, and he could have escaped by running through a bean field, but he refused to do it. The priests are saying, yes, that's true. Okay, I wondered about that one, but now we have it from good authority. He also, though, and why would a mob want to chase him? Because he had a secret society. That's what I think. They worshiped numbers. And one of the secrets was so disruptive to their ideas that if anybody let it out, the penalty was death. That idea was that there were irrational numbers. The square root of 2 can never be written as a quotient of two integers. He also had, he foresaw some modern ideas. For example, being kind to animals and women's equality. You can see it right here in the picture where he's lecturing. He's lost one woman, but the rest are paying rapt attention to him. Now we come to Euclid. I guess you all know there's a street here, not very far from the Greek church, called Euclid Street. Okay, I am not going to talk about the wonderful things he did in geometry, because I'm going to audition to be a consultant for my big fat Greek wedding 4, when I tell you what he almost did. What he did do, of course, was put geometry on a rational basis, where he started with 5 fundamental truths that he did not prove. He said, I can't prove these 5 things. They're called postulates. And the 5th one was that if you have a line and a point in a plane, you can only draw one line through that point that's parallel to this line. If you try to do this, it's going to intersect down here and all that. For almost 2 millennia, other mathematicians thought Euclid missed something here. He should have been able to prove that from the other 4 assumptions. But they never could do it, never could come up themselves to beat Euclid at the game. And finally, in the 19th century, 2 mathematicians thought, well, maybe it doesn't have to be that way. And they developed mathematics, these 2 guys. This guy, Lobachevsky, if you know the Tom Lehrer song, it makes fun of him in there, or uses him, that doesn't really make fun of him. They developed geometries in which you could have many lines going through it, or none at all. So this would be a flat thing where you can have only one line parallel. If you imagine now this 2-dimensional thing to be all there was to space, there's only no great circles. All great circles intersect. You can draw no lines parallel if it's shaped like that, if that's what space was like. And if you wanted infinitely many, it would be sort of saddle-shaped. Now, these are not really the way to look at it. We can't look at it because we're humans. We don't understand curvature of space, but the mathematicians could describe it. So what is the big thing that Euclid missed? If he had understood that this was arbitrary, then, and you're supposed to laugh at this, and he did their math of these guys, he could have proved Einstein's theory of relativity, because he postulated that space was warped and things were trying to move in straight lines across that space, and they couldn't do it, and that was gravity. That was the illusion of gravity. I'm not going to say any more about that. I'm going to wait till I get the offer from the company. We come to I call her the patron saint of the young mathematicians. This is Hypatia. She lived in Alexandria, which was the center of Greek learning ever since Alexander the Great founded it. She lived in a turbulent time when the Christians and the pagans were arguing about this. I'm sorry, Father, you're not going to look good in this one. So, but let's get back to Hypatia. She was a looker, as you can tell. She didn't have much interest in men. That's true. She only cared about her math, and she proved some theorems. She also was a teacher, and she believed in teaching Christians and pagans equally. We were all equal before mathematics. Well, that did not work well with the cancel culture of that time, and so she was murdered by a Christian mob. And that made her a martyr above everything. And I know that the church is now sad about it, right? No, they're glad you did it. Get rid of them all. Okay. There is a great movie about this. I saw it with my daughter. You should too. It's called Agora. It tells a story. I warn you, it's R-rated, so don't show it to your young daughters. But once they're in high school, they will love it. And let's go on now to the evil eye. This is a strange thing that if you haven't heard it before, you're going to think I'm making it up. When I first read about it, I didn't believe it in high school, and then I had to rediscover it. You know, you can't go anywhere in Greece and not see this for sale, or Istanbul, or around the whole Mediterranean. Why? What was the power of the evil eye? Well, I'll tell you what the Greeks thought of it. They actually could use that to explain the Medusa. You look at her, you turn to stone. Or she looks at you and you turn to stone. How did that work? They thought vision came from your eye and went out. They thought that's how you saw. You sent out rays of the element fire, which I'm going to talk about later, about fire. Oh, you're looking at me like that's funny, but wait till you see the end of this, the next 2 view graphs. There's obviously some proof. Just look at a cat. Some of you got cat. Look at a cat at night. Now, we know now there's a reflective coating back there so the light reflects twice and all that. But to these guys, that seemed pretty good. And even Plato, he had a theory about why, if things came from your eye, why did you need the sun and the moon to see? He said, well, the sun creates an aura, a body of vision there by letting loose the fire atoms out of the object so that your eyes could bounce off of it. If you'll accept my idea about almost inventing general relativity, I'll tell you that this looks a lot like a hologram. Now, all right, how crazy is that? Well, even in the Renaissance, oops, I missed one. Aristotle figured out why we could see better in the daytime. He said the sun rarefies the air so the rays could pass better as well. But even in the Renaissance, he thought it was an open question. It wasn't until Isaac Newton got the prism and the sun's rays and came up with his corpuscular theory that we now decided that's not the way it works. But they were wrong. And the Greeks were wrong on this. I'm now going to go through a list of Greek inventions. The astrolabe, I'm an astronomer after all. This allowed very accurate measurement of solar angles, and I'll tell you later what they learned from those angles. Plato invented a clock, a water-powered clock. He had a big cistern here of water, reservoir, and it would spill into this little tube, which would gradually fill up. On top of that tube was a float with little balls, and when it got to the top, the balls would spill over, hit the gong, and wake you up. Nice, huh? I'd rather have that than some of the alarm clocks I've had to deal with. But that got taken further, of course. In Alexandria, the father of pneumatics had a very complicated water clock, which served as an alarm, and it actually was the most precise clock for over 1,000 years, until Galileo conceived of the pendulum clock and Huygens built one. He did other things too. You're not going to find anybody that I'm talking about that did only one thing. He invented the siphon and the precursor to the pipe organ. He and his wife used to have concerts where they would play that. Now we come to the first steam engine by Hero of Alexandria. Water would be boiled in here, turned into steam, then it would go up this and go into this little thing there that's free to turn. So the steam would come out of this end and out of that end, which would give it the momentum to go round and round. Now, he only thought of that as a toy. He did not go on to make a real steam engine that did work. I have a theory as to why, but I'm not going to tell it to you. I mean, you can come up with your own theories about it. There was a paper that I saw about it, but it was behind a paywall, and I just saw it, and I didn't go look at it. We're coming now to the Antikythera mechanism, which I understand there's going to be a talk here about. It's called the world's first computer, or the world's first calendar. It was found in a shipwreck about 1900 by some sponge fishermen. One of them got so excited finding the many artifacts that he actually stayed down too long and got the bends. And this is what came up. The story of how they realized what that was is an interesting story in itself. And if that talk happens, that's here. The talk's here, right? On that? You will see. You should go to it. There was a Scientific American article about it, maybe 2 years ago. With X-rays and other things, they realized that what they were looking at was a dial here that had months and many different systems and many gauges to read things out, and it had over 69 gears that they could find. From this, people were able to infer, and they argued a lot about the actual inferences. It's a big intellectual achievement. That this is what the customer was getting that sunk in the shipwreck. They could tell you when the planets were rising and setting, and stars rising and setting. It could predict eclipses, the months and the systems of many different cities, because they had different ways of telling the months back then, and even the Olympic Games. Plus, there was a user's manual. If you opened up this one, there was over 1,000 characters describing how to make it work. Let's go on with the show. This is an exciting thing. You might wonder, how did they predict where planets would be when they thought the sun, they didn't know the sun was at the center of the solar system. It was epicycles, which were circles on top of circles. Here is an interesting fact that many of you know. If you look at a planet like Mars, this is Mars, and watch it over time, it doesn't go in a straight line. It goes in a zigzag motion. This is a picture like every day, how it would be, or maybe it's every other day, I don't know. It goes this way and goes back and there. What to make of all this? The Babylonians, who invented astrology, the Greeks actually didn't learn astrology till Alexander the Great conquered those parts of the world. They thought these were gods, and that was when the gods were mad, and they called that retrograde motion. So if Mars is in retrograde, you do not go to war, and never get married if Venus is in retrograde. No. So how did the Greeks think of it? They didn't have gods doing this. They thought, here's the Earth. Mars goes in an orbit like that, but it goes in a circle upon the circle, so the actual motion was like this. And as they got more and more data, they had more and more trouble making it fit, so they added more and more epicycles. At the end, Ptolemy, who I can't talk about, you'll hear his name a few times though, he had almost 100 epicycles describing how the solar system worked. What do we think it works now? Well, we got the sun here, and we know the Earth goes faster around the sun than Mars does. So if you look at position 2, here's the Earth, and we're from the perspective, and you look at Mars across the star, you see Mars up here. But then as the Earth whoops up to position 3, then Mars is up there. But when you get to 4, the Earth has passed Mars around, and now you see Mars going backwards. And then eventually the Earth goes fully around, and then we see just Mars's motion again, so Mars reconsiders going. That's the current theory. And the movie called Agora makes a lot out of this, with Hypatia. We come to Archimedes. I forgot to mention that the Roman Cicero thought that Archimedes, who's arguably the best mathematician who ever lived, they thought that Cicero wrote that Archimedes probably invented some calendars like the Antikythera mechanism. So, but we don't know if he did or didn't do that. This picture is on the Fields Medal. The Fields Medal is the highest medal a mathematician can earn. There is no Nobel Prize for mathematics. A lot of people say it's because Mr. Nobel's wife had an affair with a mathematician. We don't know that. So what was he good for? He proved many theorems. He was able to get limits on pi, or even 2 pi, by the pi, that's the ratio of the circumference of a circle to the diameter. He did it by drawing figures, and that's an irrational number, so you can't get it exactly to whatever you want, but he was able to get figures inside of it that he knew that those lengths were less than the circumference, and he drew things outside of it that were bigger. So between that, he was able to bound pi. And also an interesting thing that was found to show what he had to deal with was he wrote a proof that the number of grains of sand in the beach were not infinite, as many people used to believe in those days. Okay, now we come to the famous story about him putting the gold crown in the water to measure its volume. How many of you people know that? That's all? You're nodding, you know it. Okay, I'm going to assume you all know it. Okay, so he discovered that the way you could tell if that crown was pure gold, put it in the water, see how much the water went up. I told you the volume. And yes, he ran through the streets to tell the king in all excitement. Those of you who know Greek know he shouted, Evrika, Tovrika, which means I found it. It's translated as Eureka. That's where that word comes from. But we are not done with him. You see some empty blanks there. He invented the Archimedes screw. Take that thing and you can stick it in either in a well and bring up water or in the ground and dig up dirt. He was very much into those kinds of things and levers. He famously said, "Give me a lever long enough and a place to put it on, and I could lift the world." I have a very fond memory of my father when he was 95. There was a caretaker who was trying to open this can. It wasn't a school can. It had one of those lids had a lid that you had to pop open. And she was using a very small knife to try to open it. She couldn't get it to open. My father went to the garage, got a big screwdriver, when boom, off came the lid, and then he told her this story. Are we done with Archimedes? I don't remember. Ah, yes. No, we're not at all. He used science to help his city-state, Syracuse, when the Romans attacked. You see, it took them 2 years to conquer it. What are some of the devices he used? He built big lever things. This is an artist's conception. Levers that could reach out and grab the ships and destabilize them so they couldn't come close to shore and land soldiers. He also designed many catapults that could throw rocks or fire at their ships. And he set up mirrors along the shore that could focus the sun's rays to set fire to their sails. He had the Romans so freaked out that one time when they were attacking the walls, he just stood up there and looked at them. They ran away. But yes, they won in the end. How'd they do that? There was some festival for the gods, and the Greeks were distracted by that, and that's when they attacked and took the city. But the Greeks had the last laugh because they took the sundials off as booty of war. They took them up to Rome. They didn't know anything about sundials, and they didn't know that they were calibrated for Syracuse, so they didn't work right for Rome. Worse, it didn't take long before the Romans didn't want them. Here's what a comic poet said: "May the gods confound the man who first set up a sundial. Before my belly was a sundial and I could eat whenever I was hungry." So I mentioned fire. Greek fire wasn't developed by him, but Constantinople had it. They beat off several Arab fleets, and that helped them survive. We still don't know what it was made out of. We think it was made out of these substances. Now, I used to work for the Navy. It might be the Navy does know what it was, but they're not saying. Science was good for more than war. This is Hippocrates of the island Kos, which is very near where I come from, Carpathoz. He championed the idea that diseases have natural causes, and he thought a lot of it was due to the imbalance of these four humors. And he recognized that PMS was a serious problem with women. It wasn't until the 1920s that modern medicine decided PMS was real. Before, they thought it was some crazy thing in women's heads. For diabetes, he prescribed a low-starch diet and exercise, which is excellent if you don't have insulin. And he often prescribed common sense things like rest and immobilization. He's known for saying, above all, do no harm, patient confidentiality, and master and slave equally. Now, I'm not saying he was a big liberal. I'm saying that he knew about communicable diseases, and that's why. And of course, the Hippocratic Oath. I looked this up at dinner today. About half of the medical schools require their graduates to say some version of that oath. So how well did this stuff work? If you look at the London Museum, there's a plaque that was found on my island of Carpathoz awarding a gold wreath to this doctor who cured them of a plague. But if you want to talk about plagues, you got to talk about the Greek doctor Galen. Marcus Aurelius, the emperor, chose him to be his personal physician, but he sent him back to Rome to take care of his son. Now, if you saw the movie Gladiator, I got to tell you, I've looked into this. Commodus, that's the guy in the movie, the emperor, but he wasn't nearly as evil in real life as Hollywood made him to be. He was, however, incompetent, but he made up for his incompetence by being lucky, because Galen was there, and he treated him and all Rome during what's called the Plague of Galen. We don't know what that was. It might have been, from the descriptions he gave, the detailed descriptions, it could have been measles or smallpox. He did many other things too. He dissected primates because it was illegal to dissect people. He proved that the brain controls the body and not the heart. He studied the circulation of the blood, and he came up with the idea. He didn't know about capillaries. He thought the circulation happened through little perforations in the heart. But he did surgery without anesthesia, but he did it. And this is actually bigger than you might think. When the microscope was discovered, people discovered sperm. When they used it, they discovered sperm. And the prevailing theory was that the sperm was everything there was the baby, and all the egg was food for the sperm to eat. Not exactly true. And he took it a bit further about diseases. He thought the moods were due to these things. And you can associate that with hormones. That works. He anticipated Freud with the ego, the superego, and the id. He wasn't perfect, though. He brought bloodletting to Rome. Now, who's next? The father of history, Herodotus. Why they call him the father was because before then, anything written in history, its purpose was to glorify the king. But he tried to figure out why things happened and be analytical about it. I'm going to give you two instances of this, skipping all that he wrote about the Persian Wars and all those things. One was, he discussed the claim that the Phoenicians made that they had sailed around Africa. And he said, well, the Phoenicians also said when they did that, they said the sun was in the north part of the sky. But everybody knows the sun's in the southern part of the sky. So he didn't believe that. He didn't know the world was round. But now we can turn that the other way and say, yeah, the Phoenicians really did it. The other thing he said, which wasn't believed, which he said it, but nobody believed it. He said that up north, there were some barbaric tribes that drank their victims' blood, and they used the skin of their dead enemies for the quivers, their quivers, when they went to war. Well, just in the last issue of Archaeology Today, bingo, they did some grave searching above the Black Sea, and they found human skin in 2 cases, confirming Herodotus. If Herodotus was a father of history, Thucydides was a father of scientific history. He has an interesting story in himself. He was an Athenian general at the start of the Peloponnesian War, and he was commanding some forces in northern Greece when the Spartans landed at the key city of Amphipolis up north and surrounded the city. Amphipolis sent word out, help! Thucydides brought his armies, led his armies to save the city, but before he got there, the Spartans knew he was coming, so they offered very generous terms to Amphipolis to surrender. Amphipolis accepted those terms, so when Thucydides arrived, there was nothing to fight for. The Spartans had the city. The Athenians didn't like that, so they exiled him, which was bad for him, but good for history, because that left him free to go around Greece, talk to both sides, and write an impartial study of the war, of the Peloponnesian War. His technique was to rely on eyewitnesses, but admit what he couldn't. I was very impressed by this when I was a kid and I read him, because he starts in his preface that when he describes what happened when a peace delegation would go to a city, he wasn't there, so he wasn't writing what they said, he's writing what they should have said. And I remember thinking, if they had said what Thucydides said they should have said, maybe the Peloponnesian War wouldn't even have happened. But He did not moralize. So you typically present the facts, both viewpoints, his own opinion, and let the reader decide for himself. Here's a quote that I recently found that I think everyone will agree to today, be they Republican or Democrat. Democracy needs leadership, but leadership can be dangerous to democracy. We come down to the atomic theory. This is the earliest reference I could find to it. 4 elements. I learned about this actually in junior high school. They would bring it up in the chemistry of the thing. And the example that they typically give is burning is when fire atoms leave the wood. The fires left the wood. What's left behind is the earth, which is the ashes. Heraclitus, who's probably best known for saying, as a philosopher who said you can't step into the same river twice, he raised fire to the supreme element. Democritus is typically credited with the theory. He thought there were infinite kinds of atoms. In modern Greek, atoms means individual. So if you say, I want to ask how many people were in a car, you say how many atoms, atoma, are in the car. And that's how you get it. Modern science didn't really believe in the atomic theory, that is completely, until Einstein. In 1905, he published a paper explaining Brownian motion, which is germs, microbes. If you look at them under a telescope, they seem to be going along and then they jump. Walking along and then they jump. He explained that as them being whacked by molecules, thus establishing the atomic theory. We come to Aristotle. He was the taxonomy, 500 species. He classified. He described humans as political animals. I think we'd all agree with that. And in terms of geology, he thought the Nile Delta was not just formed that way. He thought it built up over time. He had a concept of the earth transforming. And he thought volcanoes would shape the earth. In astronomy, he thought the Milky Way was a byproduct of stars burning. We now know it's a bunch of stars that are too far away to make out. But note the key thing. He thought that stars were burning. He also experimented with helping desalinating seawater. And he was an advocate of the healthy diet. We all know that the Mediterranean diet is about the best thing you could eat. And if you go to Athens, you can find a place where they give you the Aristotle menu. He did not have tomatoes. Those are a New World thing. So I recommend bring your own tomatoes if you want to go there. I took them, man. Here's a comparison of me and him. You can decide who's right on this. When I got first promoted to be head of time service, it's not like winning the Nobel Prize, but everybody thinks you know everything about time, which of course is ridiculous. And so the Encyclopedia Britannica asked me to define time, and that's the definition I gave, which I've been thinking about before then. You can still find it, I'm surprised to know, on the internet. That coordinate that can be most simply related to the evolution of closed systems. You hear that? Now, I wondered what Aristotle said about time. Well, here's what he wrote. The number of change, I think this is a horrible translation, but that's what he wrote. I think it's basically the same. I used a lot of highfalutin language, but he had the essence of it. I'll give him that. But where I'm going to argue about is on the next view graph about octopuses, which are what I like, species I really like. He called them mollusks. I think we'd all understand that. I'll submit that I'm going to tell you things that not everybody here knows about octopuses. He knew they escaped enemies in a cloud of ink. Okay, we know that. You know they don't live long, especially after mating. Did you know that the males had a large tentacle that they used for copulation? Well, many of you did. In fact, in some species, the male gets close to the female. He just gets close. He gets into a frenzy, and he hands her the sack, and she takes it, and then he goes off to die a happy mollusk. And she lays her eggs, doesn't eat, and guards them until she dies. In other species, he actually has a spot in her body to put them. He called them stupid. That's what I'm arguing about. And what was his example? He said, if you hold out your hand, they'll come in it, and then you can grab them and eat them. Well, I say they're just foolishly curious. Again, you guys can decide. I'll play the Thucydides here. And go on. Let's see what else about Aristotle. The world round. I don't know if Aristotle was the first human to realize the world was round, but he certainly was the first person to publish it. And in those days, they weren't big on footnotes. It must have been in that Greek period, though, maybe by discussing that he realized it. What were his proofs? The shape of the Earth's shadow in a lunar eclipse is round, which is also an advancement. A lot of people were still thinking an eclipse was when the wolf is eating the moon or the sun, but they realized it was due to the sunlight. And when a ship is coming into Athens, first you see the top of the mast, and then you see more and more. And the North Star gets lower as you go south, and new constellations appear. So those were his proofs that it went round. Now, here's what people like to criticize him for. He thought the Earth was the center of the solar system, and Aristarchus said it was the other way around. He came after Aristotle. So we could look upon this as a next step in Greek science, not necessarily that Aristotle just was a total arrogant person who didn't know anything. Actually, I have a backup view graph where I show all the reasons, even in the 1400s, why people argued that the Earth had to be in the center. But Aristarchus said that. He actually was superseded by two Pythagoreans. One of the reasons they didn't believe him was Ptolemy, this astronomer that I'm not going to talk about. He realized that the rotation would tear the Earth apart. If you're rotating, you're going 1,000 miles an hour. They didn't have a good theory of gravity because Euclid missed it. But let's go on. Aristarchus did other interesting things. He figured out the relative size and distance of those to find how far the ratio between the moon's distance from the Earth and the moon from the sun. He realized if you look at it when it was half full, you could then measure this angle, and then by trigonometry or other geometry, you could know the relative distance. He got the wrong answer. He got the sun 20 times further away. It's actually much further than that. But this is a very hard thing to measure. The moon has structure, and it's all that stuff. He did better on measuring the size of the Earth. Oh, sorry, I haven't gotten there yet, because he didn't do it. He measured the relative ratio of the Earth and the moon by looking at the moon as it was coming into the Earth's shadow at an eclipse, and then how long it stayed in. He got a moon size being 1/3 the Earth's size. It's actually 1/4 the Earth's size. The reason for that discrepancy was because you had to use this number in it, and he had that number wrong. But he was on to something. Now, I stole my fire. Here's Eratosthenes. He actually measured the size of the Earth. He was an Alexandrian scholar, and he heard that in the town of Syene, which was south along the Nile, at the sun's highest point, at the solstice, its light would go directly down a well. Whereas in Alexandria, it would come in at an angle. Well, that was a simple geometry problem if you knew this distance. That was easy to measure, and so he got the size of the Earth. He said it was more than 39,000 and less than 40.3 thousand miles. His units were actually stadia, but we know how to convert. And he was right on. The actual value was there. Notice the other interesting thing. He had the idea of plus or minus. The inaccuracy of a measurement went into what he was doing. This guy was actually quite a guy. His day job was chief librarian. But look at all these things the guy did. I mean, all these things. They call him the father of geography. He coined the word, all of those. And he wrote poems. I'm going to talk about two things, though, because I want to get on to finish the talk. One is he used Egyptian and Persian records to date the Trojan War. So I want to ask Mike, who actually has excavated Pylos, and the oldest language in Pylos, how close did he come? Off by 60 years. Well, not bad. It could be worse. He also came up with the idea of leap years, which is intrinsic to the discussion of the calendar. We'll take an aside and talk about Hipparchus, the father of modern astronomy. Here he is with his invention. He invented the armillary sphere, which was sort of like an astrolabe on steroids. Let him make a very good catalog of the stars. In the 1990s, there was a satellite system called Hipparchos, whose job was to measure the positions of the stars in our galaxy, and it taught us a lot of things we didn't know about the motions of stars there. He also discovered precession. How many of you know what precession is? My mother told me that when I was little. The Earth has a wobble. If you look straight up from the North Pole, you get to the North Star, Polaris. But if you wait 2,000 years, going up from the North Pole, you'll see nothing at all. It'll take 26,000 years before Polaris comes back again. Why does it have a wobble? Because it's rotating. That gives it a little bulge, and then the planets, with their gravity, play on that bulge like a top, and they make it wobble around. So Hipparchus discovered that by comparing his data with ancient data from the Babylonians. He also, he's credited with inventing trigonometry. I think that might be a strong statement, but he certainly advanced it a lot. He did predict solar eclipses using a cycle by an Athenian that they occur every 19 years. But he was bested by a woman. Plutarch says that she was so good at predicting eclipse, they accused her of being a witch. Finally, we come to the calendar, the last part of the talk. The basic fact of calendars is that 1 year is that many days. It's not an even number of days. If it was exactly 365, it'd be very easy to keep track of things. Most of the places in those days did not even try. They just had a lunar calendar. And the Jews, for example, would have 12 lunar months, 29.5 days each. And so their year would fall behind the actual year. And when they fell a whole month behind, they just add another month to bring it on up. The Romans were worse. And always, the priests controlled this. And if the priests in Rome liked the person in power, they give them an extra month anyway. It's very good for funding. And so that all changed when Julius Caesar went to Alexandria. There was a Matsakis lecture a few years ago about how when he went there, he met a very intelligent and pretty Egyptian princess known as Cleopatra, and that's the romantic part. He also met this guy, the astronomer, who told him about Aristophanes' idea of a calendar. Caesar liked it. So he took it to Rome and he named it after himself, the Julian calendar. And in this calendar, every 4th year is a leap year. So that approximates well, if that's how long a year is, not exactly right. He was so pleased with that that he also took the month of July and named that after himself too. So that's where we get July. But there was one problem. It had gone so much out of sync that we had to bring it back again so that the equinox would be on March 20th, the equinox being the first day of spring or the last day of summer. And so he had 1 year, which was 445 days. If you ever hear about the year of confusion, that was it. That was it. So this worked very well for a long time, but these numbers were not exactly right? Didn't exactly line up. And when we come to 1582, Pope Gregory the 13th got worried that Easter would be computed the wrong time because it had gained about 11 days or something since then. So he called all the experts, the astronomical experts, the best ones that he had at his disposal, and they came up with a new system. They would skip a leap year every 100 years, except if it's divisible by 400. With that system, and they also jumped the calendar, I think 11 days, you could look it up. So 1 year was 365.2475 days, much closer. The world didn't accept it right away. Queen Elizabeth would have nothing to do with the Pope, and neither did the Orthodox religion, but one by one, the countries came along. The Russians didn't do it until after the communists took over. But the Greek Church never did that. And that's the reason we get to the discrepancy, which I'll now explain in greater detail. In 325 AD, Constantine the Great convened the Council of Nicaea, whose purpose was to standardize Christianity. As a persecuted religion, they had many offshoots with many different ideas, many different versions of the Gospels in the Bible. So he convened all the experts to figure what was real and what was not. They threw out a lot of stuff. Some revisionists think they threw out too much. But in terms of Easter, here's what they decided. I'm not going to go over these facts. There's too many of them. They did all that, and they could have done it the Jewish way, where they compute the full moons like the Hebrews did, but they didn't. They were so used to the Julian calendar. I think that's their motivation. I'm not going to call it anti-Semitism. They were so into that, they just decided Easter would be the first Sunday after the first full moon after the spring equinox, which was basically March 20th, give or take a day. So that was it. Wait for the equinox, wait for a full moon, and next Sunday, Easter. And that was the Julian calendar. And only the Julian calendar was around then. So the Orthodox used that. The Catholics used the Gregorian calendar. They also use different tables for the ecclesiastical moon. The moon's orbit is hard to predict because it goes around the Earth, but the sun is very strong and it yanks it around. So they never quite got it right. There's all these cycles. So rather than risk not being able to compute it correct in the future, they wanted to have a number. They defined this new concept of a moon that was divorced from the real moon. And then Pope Gregory revised that too. So let me show this in pictures. Here's the time of the Gregorian calendar. That's their equinox. When you come to April 2nd, that's the equinox from the Julian calendar, but the Orthodox call that the equinox. Here comes the full moon. You see one there, that's before anything, so that doesn't count. The next one would be 29 and a half days later. Over there, that's after both of them. So they both agree that that's the right full moon, and then they'll go the next Sunday after that. And because they have some slight differences about the tables, they might be off by a week, but they come in line. But what's the other possibility? The first full moon before the equinox, or the last one, is over here. Then if that goes 29 and a half days, the Catholics say, aha, now we can get the next Sunday after that. But the Orthodox say, no, you have to wait another month. That's why it can differ by up to a month or even more. So that's the reasoning. Now, who is more accurate? Well, I did a table. I looked at the last 25 years. I'm not going to go over this. I used the real equinox, the real full moon, and computed what it was and see who wins. Well, I'm sorry to tell you, the Catholics win hand down on this one. But wait a minute, we got at least one lawyer here. Why do we have to go by the Council of Nicaea's rules? Jesus was a Jew. What if we computed it the Jewish way, adding a lunar month every now and then? That's the calendar he followed. In that case, it's a dead heat. I'm going to go one further in my last slide and tell you that Greece has more accurate calendar than any other country in the world. Here's why. You hear that? The most accurate calendar. Here's how. Here's why. In 1923, the upper echelons of the church and the Greek government went in Constantinople, and they consulted with the best science of that time, in particular, the Serbian Milankovic. Some of you know who he was. He came up with the Milankovic cycles, 40,000 years, 100,000 years, and these were cycles of how the planets pull on the Earth's orbit. Sometimes they push the Earth further away from the sun, and we get an ice age. Other times they push it back, and the Earth warms up again. So they consulted with him, and he came up with a plan. But before I tell you the plan, they decided in their wisdom to retain the Julian calendar for the most important holiday. But for everything else, they adopted a revised Gregorian. He had a different order for skipping leap years than the Gregorian, and it differs starting in the year 2800. So his different pattern differs from the Gregorian calendar by these. If you follow his system, you get the exact same right answer for how long a year is. So you've got 800 years for the whole world to either follow the Greek way or else to be off, to be wrong. So that's how it goes. Now I'll come to the conclusions. Science itself got its start with the Golden Age of Greece. No, not necessarily perfect. Sometimes simple, but other times not so simple. Its contributions continued to Rome, to the Renaissance, to today, and to the year 2800. Yeah, okay.
We have a few minutes for questions and discussion, so the floor is still yours.
No questions. Okay.
Sorry, go ahead.
I didn't credit him with algebra. We had to leave something. And some people say trig, too, came from the Arabs. I think people learn more and more about these things. And so you can decide when you want to say it really got founded and who contributed what. Oh, yeah.
Global warming.
Good.
About what the Serbian said
Yeah.
is the global warming that we're experiencing today because of that theory?
No. No. Here's the thing, that the Earth has at times been much hotter than it is now. The dinosaur days, most of it. And it was an ice box, too. It was covered with ice in the early period, and then volcanoes came and melted the ice and let oxygen and formed carbon dioxide. The argument about global warming is the humans are dumping so much into it that it's rapidly changing, not over 10,000, 40,000 years, but over 100 years. So the animals and the insects, everything can't adapt to it. So it's a matter of the rate that it could do it. But you don't want the dinosaurs to come back, do you? So keep it away. Actually, they're still here, the birds.
What was the connection between Arabic and Greek science?
The Arabs, indeed. Oh, sure. There was a lot of interactions between all of them. I'm not qualified for that either.
But has Greek science influenced Arabic science?
Oh, of course. Of course. In fact, a lot of people credit the Arabs for preserving what we knew about Greek science, because some of their things, that's how they came to us. And I even read a book where it said they went from the Arabs to Ireland, and the Irish monks saved a lot of Aristotle's works and other works. And at the end, you know, it's all a fabric. We're all related. It goes from one to the other.
Thank you very much. I think what you just said is very wise and very relevant. Everything is connected. Everything is interconnected. And sometimes we make the mistake of thinking that our world today is disconnected from the past and from previous cultures, but that's not really true. We're part of the same cultural continuum. And what those people, all those people that you mentioned, and honestly, until I heard from you all of these discoveries together, it hadn't sunk how many scientists there were there and how much they discovered that has shaped our world. So thank you for making this so clear for us today. Oh, you knew it all, I'm sure. So two things before I close the evening. Number one, I'd like to thank Bob L., who is the heart and soul of all the events that we're doing. Bob is doing all the work behind the scenes, and Bob, thank you very much. And also John, who has been doing the recording and the webcasting. Number two, this is our last event for this academic year. The next event will be on September the 22nd. It will be the Spanos event, and it will be special because we will celebrate 30 years of the Greek professorship. It will be almost 30 years that this professorship was founded. So we're planning a big event. During that event, we'll present several projects that have been in the making, including a documentary on the history of the Greek community, which is done by Mr. Tom Bellos over there. The books by Professor Poulopoulos. We're organizing a digital exhibit for the history of the Greek community, including all the family histories, the histories of the organizations, of the Greek organizations. So everything will be done and presented on September the 22nd. Mark your calendars. Thank you so much for being with us tonight. Demetria, thank you for a wonderful lecture, and both Ilya and Dimitri, thank you for your friendship and your love of this and your support of this professorship. Thank you. Good night. Students, come and find me.